in this question, we have to distribute 20 identical balloons among 4 children, such that each child gets some balloons, but no child gets an odd number of balloons. Or in other words, each child gets an even number of balloons, right? So that is basically what has been told to us, and at least 2 balloons, because 0 is not permissible, 1 is not permissible because 1 is an odd number. So every child needs to get at least 2 balloons. So let's say, for example, we give those 2 balloons to each of these 4 children, and we are done with that basic part. Now we can say that one child plus the amount of balloons by the other child plus the amount of balloons by the other child plus the number of balloons by the 4th child should cumulatively be 12. Why 12? Because I have already given 2 balloons to child A, 2 balloons to child B, 2 balloons to child C, and 2 balloons to child D, right? So 8 balloons have been given away. Now I have 12 balloons. I can distribute it however I want to, right? I can distribute it the way I want to, purely because I would have already given 2 balloons to each child. So I can choose to not give anything. I can choose to give 2 balloons, 4 balloons, all 12 balloons to one child. Anything is possible. But because I have given an even number of balloons to each child initially, I need to give an even number of balloons to each child now as well. Because now if I give 1 balloon to the first child, that child will have 3 balloons, which violates the condition wherein each child should have an even number of balloons. The way to handle this is, let's say I give 2 A balloons to the first child, 2 B balloons to the second child, 2 C balloons to the third child, and 2 D balloons to the fourth child, where A, B, C, D can be 0, 1, 2, 3, 4, 5 or 6, right? That is basically what I am doing. Now in this particular context, the total number of balloons is 12. If I just cancel out a 2 from each of these terms, I am going to get A plus B plus C plus D equals 6. Now I can choose to give all 6 to A, in which case A will have the initial 2 balloons plus 12, that is 14 balloons, and the remaining people will have 2 balloons each, possibility. I can give 3 balloons to A, 3 balloons to B, or I can make A equals 3, in which case A would have got 6 balloons in the second distribution, B would have got second balloons in the second distribution. It's fairly possible, right? So all these will basically be the solutions to our equation. So in this case, what is the number of solutions for this? We know that the number of solutions for this is n plus r minus 1, cr minus 1. In this case, n is nothing but the number of objects, 6, plus r is the number of parts, that is 4, minus 1c, 4 number of parts minus 1. So we are going to get 9c3, which is nothing but 9 into 8 into 7 divided by 3 into 2 into 1. How did I get this? This is 9 factorial by 6 factorial, 3 factorial. So 9 into 8 into 7 into 6 factorial gets cancelled out, and so I am left with 9 into 8 into 7 by 3 into 2 into 1. So 3 3s are 9, 2 4s are 8, 3 4s are 12, 7s are 84 is the answer to this particular question. So there are 84 ways of distributing 20 identical balloons among 4 children such that each child gets at least 1 balloon and no child gets an odd number of balloons.